Hello friends, today we are continuing our model with the design part. As you have already seen the analysis part in previous video. If anyone not seen yet, please get the link in description box or in the I button above. So let's start for the design. For this we have all said in previous video you have seen the analysis part. So we are going to design. Go to design. This is our RCC building. So in go to the concrete frame design option, go in first option, view revise preferences. Here are some options. First option is design code. You have to set design code. Here is ACI code as default by Etabs. We have to change it to IS456. It will take all the options from the code. You you need not to change anything. Just click on OK. Go to design. Go to select design combination. As you can see, here is all list of the combination available, and by the code selection etab will take all the combinations, design combinations itself. So click on OK. Go to design, concrete frame design, and just click on start design check. The process will be started. You can see etab is designing all the members, and you can see the progress in the progress bar. It will take some time, so you have to wait until it's completed. If you still not seen the previous video, you can get the link in description box. Please watch the previous video as I have explained the analysis part. So we have to wait for few minutes. It will take some time. So design is ready. As you can see, first we see the column, then we'll take a look to the beam. So for that, I just close beams and walls. Just make columns visible. For easy understanding, I just keep randomly select 4 columns. I just keep these columns. So you can see, we can easily understand and check the result for these columns. So for the results, go to design, concrete frame design, and here is the option display design info, design output. You can select the option, but now first we are selecting longitudinal reinforcement. Click on OK. you can see the values. Those column are passed, are giving design reinforcement, as you can see, and this column is pass, so the reinforcement is showing, and this column is fail. This is showing at this level, this is showing overstressed. As you can see, column when the column is passed, it shows the design reinforcement, otherwise it shows overstressed, as you can see. Now you can check the individual column at individual level. You can just click and right click on the column. You the this frame is appears in front of you. Now you can check the column details and everything for the column design related. For go to summary, this you have to, if you have to, if you want to quick review, just go to summary, click on summary, and you can see the summary result. This will show you the summary of design report. Now you can see here the level, column number, and the section for what combination it is designed, the length of column, all the column specification, and here is the design data. For design, the design load at this level, the moment coming over the column, and minimum the moment in two directions, M22 and M33, rebar percentage in rebar percentage, and rebar area in mm square. As you can see, all the here is the actual force, and here is the shear design data. So for this level is pass, and as you can see the rebar percentage for as per the IS code maximum rebar percentage, you can limit this by increasing the column size. You can see all the result. For shear result, you can see joint shear or the envelope. Now take a look at a failed column. You can see this column, this column is passed above this level. You can check the level here also. The level is 6 story in the size. So if you want to, so this is a failed column. We are going to revise this column. For that I am going to select base story. Here is the option overrides. You can click on overrides, go to overrides. As you can see, here are some details. Current design section, you can change the current design section. So just result, you can see the effective length factor. This is a important factor. Effective length factor, you can change this effective length factor also. So I'm just going to check for higher section. Here I have defined 4 sections for the checking for the design. So I am increasing section. So our base section is 230 by 600. So I am checking for 300 by 600. Just click on OK. Click on OK. The column is not still passed, so check for the higher section. Clicking just so click on the section, and just if you select a single member and you click on a design button, here is also a shortcut key for design. If you click on single member and design, Etab will design that particular member. As we can see, our column is passed. So we can check summary. What if we have to check first is rebar percentage for a pass column. As you see, the rebar percentage is higher, so we can increase the section. For this, I am clicking the whole column, just right click, go to overrides, and I'm taking the higher section. Click on OK, OK, and keep the all sections selected, and just click on design button. It will design just single column revised design. Now you can see all levels are passed. Go to summary. Rebar percentage is still higher. You need a higher section than that, so you have to define few more sections, so you revise the overrides. As I define only 4 to 5 sections, I have to select in between these sections also. You can define more sections so that you have to select it. Okay, as you can see, the column is passed. So another column we are going to check. We can check the middle column also. We can check this column. So just click, select the column, click on right click, and just change the section. Click on OK, select, keep it selected, and click on design. Okay, as you can see, the column is passed. You can click the column, the second story level, summary. As you can see, the column is passed. In this way, you can check all the columns. If they are failed, you can revise the column by selecting and changing in the overrides. In this way, you can change all the columns. Now we design the beams. Okay, I'm just closing the columns and making visible the beams. Okay, go to the plan, just take a look at the first slab beams. Okay, show all object. As you can see, here are the first floor plan. You can see the results, the longitudinal reinforcement result for the beams. In the column, we have seen that the single reinforcement throughout, because the column is axial member, compression member, so the reinforcement was throughout the percentages same, but the beam, there are, you can see a single beam. As you can see, a single, just take a small beam. We take a small beam, you can see there are 6 values for the reinforcement, longitudinal reinforcement. For the reading, how can we read? The first, this is the left support value, this is the right support value, and these are top the top middle and bottom middle value, and this is the bottom right and bottom left. So this is the middle value. Check for all the beams. How can you read? This is the left top value, this is the middle value bottom, and this is top right. As you can check for the all beams. As you can see, this beam is in a black color and this is in red color, so we can see this is there. We can check the first we will check the result for passed beam, so that we can differentiate between the passed and failed beams. As you can see, the same as column, here is the beam values, beam specifications, properties, the moment values, and you can see the rebar values here in this table, and the shear force values also, and there is no comment, so the beam is passed. Now we are going to check for this red color beam. I just click this red color beam, go to summary and scroll down. Here is the note that shear stress due to shear force and torsion together exceed maximum allowed, so overstressed. This beam is failed for design, so we have to revise the section. So for that, same procedure as we seen in column, go to overrides, change the section. I am taking just higher section, click on. You can see there is option ductile, you can change also ductile, ordinary or non-sway. If you select the by the viewer design procedure, you can select this. I am keeping ductile, click on OK. OK, select the particular beam and design. Still the beam is not passing, so I am checking for the higher section. Here we have the 300 by 750 was the higher section, so we don't have higher section than this, so we check another beam. Take a look at a smaller beam. In this case, when the beam is not pass or the for any section, we have to check it for how many the depth you can increase as per the specification of the building, that is the lintel level, or how much the width you can increase for your with respect to your column width. So I'm going to check a smaller beam. As you can see, there are some beam fails, so we check this beam. This beam is failed also, so I'm right click this, I'm going to increase first try. Okay, just click. So you can say this beam is passed for our another section. As you can see, check another beam. As you can see, this is also failed beam. I'm going to overrides, keep clicking the higher section, OK, and design. So you can see in this way you can change the failed beams. Just click on the failed beam, go to overrides, take a higher section, For the fill beam, you can change the higher section step by step. Click on OK. Design. So in this way, you can change all the beams. Click on overrides. OK. In this way, you can see the beam is passed. You can check the summary also. So your beam is passed. Okay. You can change all the beam that's showing in red color. So these beams are overstressed. You can change this beam by clicking and just click OK. OK. Just design. As you can see, the beam is passed. Click overrides. Take a higher section. Design. Okay. In this way, you can change all the failed beams. You can change all the failed beams on all floors. As you can see, the every level there are some beams failed. You can select the one by one layer level and revise the beams. So I just change this beam for tile. Just take a this beam is passed. So you can change beams at all levels, and you can, if there is any, you can check the results in summary or take details for flexural details, shear details, and the enveloping details. You can check all the details in here. Here are some values for the beams. As we have not set the output station, so just taking 3 stations, we have to assign the output station for the beams before analysis. So you can read all the beams. If you think the percentage of steel is going higher, in this case also you can change the beam size so that the reinforcement also revised. You can see the reinforcement also, you can revise the reinforcement. In this way you can complete all the beams for all the levels. Now we can design shear walls also, as we have taken some shear walls here and lip walls also. So for that we have to again go to design. Here is the option shear wall design. For this, go to the preferences, change code, change the rebar, you can keep all the options as it is and just click on OK. Go to design again. First view the combinations. As you can see, we have selected the shear wall options, so that the wall combinations it has taken automatically. click on OK, go to design, shear wall design, and just start design check. As there are few shear walls, it will complete in soon. You can see it will not, it is not taking longer time. So we just wait for few seconds. As you can see, the design is complete. For easy interface, we just close columns, beams, floors, keep only shear wall visible. As you can see, here is one thing, you have to define pier levels for each and individual wall. If the pier wall is missing, it will not design the shear wall, the Etabs will not design. So as you can see, this wall is not designed, so you have to break the model and then again assign the pier level for these walls. So we can check the design already designed. As you can see, I will show you. Here is the undesigned wall. Just right click on it. As you can see, it will not showing anything. If you click on undeformed shape, as you can see, the properties are not given to this. The pier level is also not given. If you click on this wall, you can check all the properties are given and also the pier level. You can see the pier level is also. So if you not give the pier level, the Etab will not design that wall. You should have to give pier level to every shear wall. So we are going to check only design walls, plans. I just close some walls. Okay, we just check randomly. I'm taking these 4 walls so we can interpret easily. Okay, now go to design again, shear wall, go to display, here pier longitudinal reinforcement, click on OK. As you can see, the steel reinforcement value is showing on top reinforcement, bottom reinforcement. As you can see, you have to just right click it and you can check all the result regarding the reinforcement design. The shear wall details, material and basic information, location information, thickness. You can see the design data here. Required rebar is reinforcement ratio. This is our reinforcement ratio. You can check the reinforcement in mm square, all in format of ratio. As it is showing in mm square, you can read in percentage also. As you can see, the reinforcement percentage 3.49 for this section. In the case of shear wall, if the shear wall fails or the percentage uh, is higher, you have to change the section by redrawing it or assigning the higher section. As you can see here, the percentage, we can see the reinforcement. You can read reinforcement values for individual. Just take a look at the lift wall also. As you can see, the lift wall also design. You can see the reinforcement. In this way, you can design shear walls also. So the design part is completed. If you want anything, you just comment in comment box. I will make video on it, and just subscribe my channel. Thank you so much.